Soren Kierkegaard said, "There are two ways of being fooled. 1. To believe what is not true. 2. To refuse to believe what is true." All the arguments put forward here boil down to one issue. Does the Earth move against a background of stationary stars, or is the Earth still and the stars moving? In the 17th and 18th centuries, scholars and scientists were beginning to accept the heliocentric model as factual, and astronomers were anxious to find an experiment that provided concrete evidence the Earth was moving. One solution appeared in the early 17th century by James Bradley, the British Astronomer Royal. His theory was that if the Earth was moving in orbit around the Sun, then the stars being still could be seen as a point of reference. If a particular star was chosen, for example Gamma Draconis, this star could serve as the anchor point. The Earth takes 1 year to make an orbit of the Sun, so if he plotted the apparent position of the star in relation to the Earth's movement in orbit, logically then, the plotted points would form a small circle or ellipsoid, a sort of reflection of the Earth's orbital movement. Bradley set up a telescope pointing up vertically to see the star, and expected over time, as the Earth moved in orbit, the line of sight of the star would fall out of vision, so the telescope had to be tilted to keep the stationary stars in sight as the Earth moved. Logically, he believed the telescope would have to be tilted several times. Bradley's experiment was hailed as a success and claimed to be one of the major appendixes of heliocentricity to this day. But European astronomers were later thinking that Bradley's evidence was tenuous and threadbare, and that there must be a better way to determine once and for all that the Earth moves in orbit around the Sun. Astronomers and scientists in Europe, however, were not happy with Bradley's experiment, believing the evidence to prove the Earth was moving tenuous and sketchy. Roger Joseph Bošković, a Serbian theoretical astronomer, tried to reproduce Bradley's experiment but using a water-filled telescope. This, he believed, would bend the starlight by refraction and slow down the light so the telescope would not need to be tilted as the Earth moved. In 1866, George Bedell Airy, Astronomer Royal, repeated Bošković's experiment using a water-filled telescope. Airy followed an accepted scientific methodology to the letter, and the records are still available to this day. Scientists and astronomers eagerly awaited Airy's results and were expecting the experimental, concrete evidence that Earth moves. But Airy's result was not what was expected, and the experiment was dubbed Airy's failure, because he could not show progressive tilt of the telescope as the Earth moved. Airy followed up on Bradley's work to prove the Earth was moving, but heliocentrists today say that Airy failed because he failed to find the ether, a mysterious substance that permeated the whole universe. This is an example of how when scientists are cornered by genuine scientific evidence, they change the goalposts in order to make a failure into a resounding success. But Airy's experiment showed clearly the Earth does not move, supporting the geocentric paradigm, where the Earth does not move, quite contrary to the heliocentric model. To astronomer-scientists, it was a failure, but to those pursuing scientific truth, the experiment was a resounding success. Why was it seen as a failure and a disappointment? Because it failed to meet the paradigm expectations, showing that the experiment was paradigm-driven, looking for evidence of what astronomers already believed to support the heliocentric model. Is Airy, an accomplished astronomer, listed in those hallowed halls of astronomy? Try to find the name George Bedell Airy in a modern student textbook, university curriculum, or glossy encyclopedia of astronomy. There may be a brief mention, but other than that, virtually nothing. It appears George Bedell Airy has been airbrushed out of history. He did, without any doubt, make many worthy contributions to other areas of astronomy, and retired as Astronomer Royal in 1881. As seen in the following photos, the plumes from erupting volcanoes can be blown by prevailing winds thousands of feet above. But where there are no prevailing winds above, sometimes the plumes go straight up, as seen in the following photos. Now, using scientific observation and common sense, how could this be the case if the Earth is rotating on its axis at 19 miles per second on the equator, while at the same time is whizzing around the sun at almost 67,000 miles an hour. When heliocentric believers are confronted with simple facts based on simple observations, science does not matter. It is the deeply ingrained belief in the psyche that carries the day. Just as it was hard to convince medieval doctors that bleeding a patient was of no use at all because of indoctrination of the masses, this practice was almost impossible to dislodge. Heliocentrists will find an answer to anything that conflicts to make it fit with their belief and call it science to justify the trillions of dollars spent on space exploration. As mentioned, astronomers, according to the heliocentric paradigm, believe the Earth has a double motion, rotating around its own axis at about 1,024 miles per hour at the equator, and traveling around the Sun at approximately 67,000 miles per hour. Back in 1887, two physicists, Michelson and Morley, conducted an experiment to find the velocity of the Earth in orbit around the Sun, and personally, for Michelson, to show his lifetime belief the ether existed. For centuries, scientists have believed that the whole of space was filled with what was termed the luminiferous ether, but until this time in the 1880s, the ether was assumed to exist. Michelson was hoping to find scientific experiments to produce evidence that the ether really did exist. The ether was believed to be undetectable, tasteless, invisible, an almost mystical substance that permeated the whole universe, including space. So when objects such as the Earth moved through the ether, it may be possible to detect the relative motion of objects such as the Earth by its effect on the light waves. All energy, whether light, sound, or electricity, can be represented as a wave-like motion that requires some medium through which they can travel, just as water is needed to allow waves to travel across the surface of the sea. The notion of the ether was believed to have been proposed by Plato and conceived by his student Aristotle. In the 17th century, René Descartes made reference to the ether, and the idea was embraced and assumed to exist by all scientists, including Isaac Newton, to be filling space. So logically, light from the sun and stars must have some medium to travel through, the ether. Albert Michelson invited his friend Edward Morley, and together they embarked on a series of experiments that produced curious and disturbing results. Michelson's hope from being a high school graduate was to detect the ether, and he was well qualified for this research. 4 years at Annapolis, 8 years at the Case Institute, Ohio, and 3 years at Clark University, Massachusetts. Michelson was talented in many ways and designed and made his own device called an interferometer for measuring the speed of light. The real purpose, however, of their experiment was to find the velocity of the Earth in orbit around the Sun, and the assumed ether became part of that experiment. It all started in Cleveland, Ohio, at the Case School of Applied Science in the 1880s. This is the idea, which is quite simple. Michelson thought that for 6 months of the year the Earth was traveling toward the Sun, and in the other 6 months is moving away from it. He persuaded Alexander Graham Bell to give him the funds to set up an experiment with which he built an apparatus he called an interferometer, which could measure the speed of light very accurately. His original interferometer, made in Germany, was inadequate, so later he acquired a bigger, more accurate interferometer consisting of a huge rectangular block of sandstone as a table, floating on a bed of mercury, where the sandstone table could be turned easily in any direction, so the speed of light could be measured from all directions, and at the same time be free from any vibrations or disturbances. The Newtonian idea was that the speed of light was pushed through the ether, in which case it should vary to the observer depending on whether the observer was moving toward or away from the source of light, and the ether may not be evenly spread and light may not travel at a constant speed, in which case it should vary to the observer depending on whether the observer was moving toward or away from the source of light, and the ether may not be evenly spread and light may not travel at a constant speed. To explain it simply, Michelson created an apparatus to send and receive a narrow beam of light to a half-silvered mirror which would allow some light through and reflect some light at the same time. They called it a beam splitter. Then the two beams were split and recombined together again. The hypothesis was that they expected to see through the lens a light spot in the middle surrounded by a dark fringe, showing partial interference. It is important to note that the arms of the cross in figure 2 were exactly the same distance in length. Both light beams would recombine at C, but according to the ether theory, there should be a delay, where one beam may take longer than the other to traverse the distance, resulting in interference. To understand how this works, it's necessary to briefly look at interference phenomenon for those who are unfamiliar with the concept. This is not as difficult as it appears. Light travels in a wave-like motion. When troughs and crests line up in phase, it is called constructive interference, and the beam is bright, as at A in figure 3, two waves in harmony. When the waves are completely out of phase, the viewer sees no light, only a black spot, as the waves cancel each other out, as in B. When the waves are slightly out of phase, a light spot is seen in the middle, surrounded by a fringe of dark, as in C. Michelson expected to see a black fringe showing the two beams were out of phase, but it was unexpectedly not the case. This is made clearer in figure 3 in terms of direction and flow of ether and light. What was expected to be seen at C? One of three outcomes. 1. A bright circular light, where the returning light is in phase with the sent light beam, constructive interference, bright. 2. Totally black, complete destructive interference, troughs cancel out the peaks, dark. 3. Or, fringe around a bright light would show partial interference. Michelson expected to see a fringe around a bright light, partial interference, as seen at C, because he expected the returning light to be slower. The result, however, of the experiment was no fringes at all, and since his hypothesis failed, he called this a null result, because there was no out-of-phase light showing returning light beams were slower. So if one of the beams of light had encountered an ether wind, there would be an expected delay. This is what Michelson-Morley expected, that the ether wind would show one beam out of phase with the other. But, surprise, the beams were synchronized, arriving at the same time. What does this mean? There is no ether? This was such a shock to Michelson and Morley, and to science. The question was, how could light from the sun be transmitted through space? Surely there must be an ether. Michelson profoundly believed in the ether, and was disappointed, blaming the instrumentation that he had designed, and considered his experiment as a failure. Why a failure? To think that all these years he had believed in the existence of an ether. The experiment appeared to prove the ether did not exist. Most scholars accept today that Michelson and Morley were dedicated and sincere researchers, and no other experiment has ever been executed with such meticulous care and attention, and repeated time and time again by other scientists also, yielding the same result. The result of the experiment was a null result, based on the hypothesis that the Earth was moving through the ether. But it could also be interpreted that the Earth was not moving at all, and perfectly still, since, contrary to expectation, both light waves arrived at the same time, and there was no delay, and no interference fringes seen. But only three conclusions were considered. 1. The ether does not exist, which means sunlight can travel through the vacuum of space. 2. The speed of light is constant in all directions. Or 3. No effect could be detected either in summer or winter. Critics argue, hey, come on, where was the fourth conclusion? The experiment assumed the Earth was moving, but it could also show that the Earth is not moving at all. This is the obvious fourth conclusion. The Earth is still, in which case it was the stars that were moving, and not the Earth. Nevertheless, Michelson and Morley were hailed as heroes, put on a pedestal, and praised. The publicity for the time, especially in science circles, was huge. Michelson and Morley paved the way to probably the greatest scientific revolution of the time, the theory of relativity. But some scientists, however, were not happy with these conclusions. Far-sighted scientists of the day realized there was a fourth conclusion that was unreported, and sooner or later this error would be seen. So mathematicians came in to offer some refinements. They believed there was a chance the experiment could be saved, if it needed to be saved, that is. In 1892, the Irish physicist George Francis Fitzgerald theorized that one of the arms on the interferometer had shrunk in the direction of motion, even though the arms were of equal length. The theory was supported by the Dutch physicist Hendrik Lorentz, who produced a set of equations that between them came to be known as the Lorentz-Fitzgerald contraction equations. Their mathematical formula claimed to prove that parts of the apparatus Michelson and Morley used had actually changed size, physically, literally, a claim which can never be falsified. The question arises, if the experiment was such a success, why would mathematicians be required? They moved the goalpost and tried to change the rules so they could win the game. The Lorentz-Fitzgerald contraction formula, as they came to be known, are seen as mathematical proofs of theoretical ideas, assuming the reality of heliocentric theory, which can never be falsified. And why would the formula be necessary if the Michelson-Morley experiment was such a success? Thousands of highly qualified scientists accept the formula as proof of heliocentricity to this day, proved by mathematical modeling and prediction. But can mathematical modeling really prove a theoretical idea? Some of the applications include the physical sciences, medical, such as the absorption of medication, civil engineering, including bridge building, and social sciences, such as patterns of election voting. Mathematical modeling is used extensively in biology and ecology to examine population for fluctuations, water catchments, erosion, and the spread of pollutants, fluid mechanics, modeling of evolving tsunamis across the ocean, and bridge design, and other applications. Mathematical modeling is indispensable to scientists, but it does have its limitations. Mathematical models do not always represent reality. It is always based on assumptions, and with Michelson and Morley, the assumptions must be made clear. It is only meaningful and useful if the assumptions are based on reality and can be falsified. The gyroscope always follows a simple rule. The directions of movement of the gyro, as shown in Figure 6, is always at right angles to the spin of the flywheel. For this experiment, the gyro will need to be placed in a gimbal, which often comes with the package when the gyro is purchased. If a table is placed firmly on the ground, and the Earth is rotating on its axis, the table and gyro must be moving and rotating also, and logically, the gyro will change direction, according to the rule above. There are simple experiments the reader may want to try, with a high-precision commercial gyro with a gimbal, which can be purchased quite easily. Experiment 1. Place the gyro on a mat on a flat table as shown in Figure 7. Set the gyro spinning and slowly pull the mat along for 60 centimeters. Observe, does the gyro obey the rule on a flat surface when it's moved? So what if the gyro now moves down a curve? Experiment 2. Use the same table and add a slope to the end of the table, as shown. Gently move the gyro along with the table, and gently down the slope. Does the gyro obey the rule? If the Earth is turning on its own axis, it should obey this rule. But does it? The expected result, assuming the Earth was turning on its axis, the flywheel would tilt. Does it tilt? But the table is on the Earth, turning with the Earth, according to astronomers. In the 19th century, scientists were eager to show the public that the Earth moved on both its axis and in its orbit around the Sun. This was the time when Isaac Newton, Henry Cavendish, and other scientists received recognition in support of heliocentricity. In 1851, French scientist Léon Foucault performed an experiment using a huge pendulum that he believed proved conclusively that the Earth was moving. This experiment was performed in a place that was high enough to support a pendulum bob of 28 kilograms, the length of the wire being 67 meters. This was accommodated inside the dome of the Pantheon, Paris, and later models were placed in other similar tall buildings. As the pendulum moved relatively slowly, it described a circle and a scattering of sand below. This experiment was declared as absolute proof that the Earth was moving, and is accepted by scientists all over the world as being proof that the Earth moves. The pendulum made one rotation in 31 hours 50 minutes, rotating clockwise. This is 11.3 degrees per hour. The pendulum wire is connected to a ball joint which hangs from the dome of the building. The claim was made that in the northern hemisphere it would rotate clockwise, and in the southern hemisphere rotate counterclockwise. The mathematical modeling is very impressive, along with modern simulations, enough to convince the believer or any interested 19th century onlooker that the Earth, indeed, does move. The very sight of the use of mathematical formulas is enough to convince most people that it must be a scientific fact and can be proven. This belief is rarely challenged, and told in textbooks to young children in schools and in universities is taught as fact. But critics claim that when Foucault's pendulum is examined carefully, it does not prove anything at all, only in the mind of the believers of heliocentricity. Lady Blunt, in The Romance of Science, says, "We believe, with all due deference to the pendulum and its proprietors, that it proves nothing but the craftiness of the inventor, and we can only describe the show and showman as deceptions. A thing so childish as this pendulum proof that it can only be described as one of the most simple and ridiculous attempts to gull the public that has ever been conceived. It has been said that the pendulum experiment proves the rotation of the earth, but this is quite impossible, for one pendulum turns one way, and sometimes another pendulum turns in the opposite direction. Now we ask, does the earth rotate in opposite directions of different places at one and the same time? We should like to know. Perhaps the experimenters would kindly enlighten us on this point. If the earth were undergoing the terrible motions attributed to it, there would be some sensible effect of such motion. But we neither feel the motion, see it, nor hear it. And how people can stand watching the pendulum vibrate and think that they are seeing proof of the motion of the earth almost passes comprehension. They are, however, brought up to believe it, and it is thought to be scientific to believe what the astronomers teach. The oscillations are not uniform, but unpredictable, as all pendulums are. They can be in the same plane, backwards and forwards, or describe an elliptical or circular movement. And the pendulum needs to be pushed to start it off. If the earth is moving, however, it shouldn't need a push at all, since the movement of the earth is enough to move the pendulum. If this was truly the case, then all pendulums on Earth would be moving due to the inertia of the Earth's movement. In 1879, Hake, while studying for his doctorate, discovered that any geometrical imperfection of the system or elasticity in the wire may interfere with the two horizontal modes of oscillation from linear to elliptical movement within 1 hour of the pendulum being pushed. Also, if Foucault's pendulum was started, it should continue as long as the Earth continues to spin on its axis or move in its orbit. It does, however, eventually come to a stop. But the Earth never stops moving according to heliocentricity. The stopping, says Foucault, is explained as dampening by the air resistance. So Foucault used an electromagnet, or mechanical device, to keep the pendulum going, which prevented it from stopping altogether. If the Earth was moving the pendulum, then logically it should continue moving, even accounting for friction at the ball and socket joint connection of the connecting wire. Also, the pendulum is located in different positions on the Earth. The closer they come towards the north and south poles, the gravitational acceleration becomes diminished as the rotation of the Earth on the axis. What would be the behavior of the pendulum on the equator? Foucault's pendulum is no proof at all. But to a crowd of believers desperate to confirm the Earth moves, it must have been impressive. So much so, there are replicas all over the world in buildings with high enough towers. What about the Coriolis effect? National Geographic describes the importance of the Coriolis effect as follows. First, of moving objects such as airplanes and rockets are influenced by the Coriolis effect. Pilots must take the Earth's rotation into account when charting flights over long distances. This means that most planes are not flown in straight lines, even if the airports are directly across the continent from each other. The line between Portland, Maine and Portland, Oregon, for instance, is very long and fairly straight. Flying, however, from Portland to Oregon could not fly in a straight line and land in Portland, Maine. Flying east, the Coriolis effect seems to bend to the right, in a southerly direction. If the Oregon pilot flew in a straight line, the plane would end up near New York or Pennsylvania. Military aircraft and missile control technology must calculate the Coriolis effect for similar reasons. The target of an air raid can be missed entirely, and innocent people in civilian structures can be damaged. The Coriolis force applies to the movement of rotating objects. It is determined by the mass of the object and the object's rate of rotation. The Earth spins on its axis from west to east. The Coriolis force, therefore, acts in a north-south direction. The Coriolis force is 0 at the equator. Is this so? Is the Coriolis effect even real? When a cannonball is fired vertically, the ball lands in the muzzle, or at most 2 feet away, but the earth should be moving so the ball will fall some distance away from the cannon. What would happen if a cannon pointing exactly 90 degrees straight up were to fire a cannonball vertically? Would not Coriolis effect move the ball significantly sideways? According to David Wardlaw Scott, experiments were done in England at the turn of the 20th century, using a cannon, assuring that there was no Coriolis effect whatsoever with respect to the earth. In the experiment, the cannon was fastened to the earth securely in a vertical position and then fired. The cannonball went up vertically into the air for 14 seconds, making the total time for it to go back to the earth 28 seconds. At the latitude in England, the earth would be traveling at about 600 miles per hour, and assuming the Coriolis force was genuine, the ball should fall about 5 miles west away from the cannon. This did not happen. In repeated experiments, the cannonball fell generally within 2 feet of the muzzle of the cannon, and in a couple of instances, the cannonballs actually returned right back to the muzzle of the cannon's mouth. There is no concrete evidence of a Coriolis effect. Indeed, if there were truly a Coriolis effect on the earth as depicted, then the artillery officers and snipers would be trained to consider the spin of the earth and have to make their calculations. As Samuel Robotham wrote, hence it would be found that if the earth is moving rapidly from west to east, a cannonball fired in a due easterly direction will send the ball from a greater distance than it would if fired in a due westerly direction. But the most experienced artillerymen, many of whom have had great practice, both at home and abroad, in almost every latitude, have declared that no difference whatsoever is observable, that in charging and pointing their guns, no difference in the working is ever required. Gunners in warships have noticed a considerable difference in the results of their firing from guns at the bow when sailing rapidly towards the object fired at, and when firing from guns placed at the stern while sailing away from the object. And in both cases, the results are different to those observed when firing from a ship at perfect rest. These details of practical experience are incompatible with the supposition of a revolving earth. If a projectile is fired from a rapidly moving body in an opposite direction to that which the body is going, it will fall short of the distance at which you reach the ground if fired in the direction of motion. Now, since the earth is said to move at a rate of 1,024 miles per hour from west to east, it would make all the difference imaginable if the gun were fired in the opposite direction. But, as in practice there is not the slightest difference whichever way the thing may be done, we have a forcible overthrow of all fancies relative to the motion of the earth. Whirlpools are often referred to as proof of a globe earth, assuming a northern and southern hemisphere. The belief is that water draining into a sink or toilet basin, or small whirlpools in a river or lake, will rotate one way or another, clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. This experiment has been tried many times, and the conclusion is a whirlpool can go either way in both hemispheres. There are other factors that need to be considered that determine the direction of a whirlpool. Sinks and toilet basins are sometimes designed to channel the water in a particular direction. This, however, is an experiment the reader can try as a team or group with members living in both hemispheres. A walk by a river or lake, a whirlpool may sometimes be seen. Take care and make note of the direction and compare it with the location. How do astronomers and scientists explain this and justify the earth is moving? Galileo explained that a cannonball shot vertically into the air would land inside the muzzle of the cannon or very close by because the iron ball remembered it was part of the earth and came back home automatically. Marcus Chown explains, "The answer is that we and the ball and the air around us were all born into a moving world, and continue to move around with the earth as it turns, because that is what moving things do." This sounds more like metaphysics than physics, but this is the basic philosophy that Galileo used. It hardly makes sense, since Galileo says that these rules did not apply to the atmosphere and the clouds. If the earth was moving, cannonballs fired west should go further, and balls fired north and south should show their paths curving to the west. This clearly shows the earth is not moving. Harold Brown, in an article, Galileo, the Elements and the Tides, suggests the gravitational pull of the earth is synchronized with every part of the earth, inorganic and organic. The rock or iron cannonball is seen as part of the earth, and contains inherent properties of the Earth. When Galileo, believing the Earth moves from east to west, noticed the sky and clouds were moving west to east in the opposite direction, Galileo concluded that the gravitational forces do not apply to the air or the clouds. If the Earth was turning on its own axis, flights from Quito in Ecuador to Singapore halfway across the world would be unnecessary. Both cities lie on the equator, about 12 hours apart. In that time, the Earth will have moved east to west, and Singapore would occupy the space that Quito occupied. This logically would mean that instead of taking a flight, the passengers could board a helicopter, hover above Quito, and 12 hours later descend vertically onto Singapore, which would have been carried by the Earth's rotation at 19 miles per second from east to west. To heliocentrists, this is a preposterous idea. But logically, if the Earth really is rotating, it makes perfect sense. Felix Baumgartner was taken up by a balloon in a capsule to about 128,000 feet and jumped. Felix landed very close to where the balloon carrying his capsule was launched. But if the Earth was moving beneath him, in the 4 minutes he was falling, and the Earth was rotating east to west, Felix would land far to the east, in the Atlantic Ocean. Some believe this may be because he was held over the launching site by the wind, but this is arguable. Almost everyone in the modern world has experienced the Doppler effect, named after the German scientist Christian Doppler, which has various applications, including in astronomy, redshift and blueshift. Imagine an observer stood in a safe position on the side of the road, and an ambulance comes along at the road at great speed with sirens screaming. At first the noise is low from a distance, but gets louder and louder as it passes the observer. Then the sound is suddenly diminished and fades away. The intense sound is caused by the approaching ambulance compressing the airwaves. As the compression wave passes the observer, the wave compression is reduced substantially and very quickly. The point here is that this experiment can be observed, and it does not matter whether the ambulance is traveling from north to south, west to east, or east to west. It always works. Now, if the Earth is moving east to west at 19 miles per second, the effect would be greater than the west to east, since the Earth is already traveling at speed in that direction. But this is not the case. It works in all directions of the compass. To learn more about this fascinating subject, please read the full book, The Lies Astronomers Tell, for free, link in the description box.